Hi, I'm Eddie Milne. I'm the Technical Sales Manager at Hexagon Veripos.
Okay. Can you briefly explain what Hexagon does as a business?
So Hexagon Autonomy and Positioning Division, which is the division that Veripos is in, provide offshore positioning to the offshore shipping industry, providing precise positioning to offshore vessels for either DP operations or survey operations offshore. And as part of the presentation, we also supply protection against that, for that positioning for jamming and spoofing events offshore.
In your presentation at the annual Offshore Support Journal Conference, you spoke about different types of jamming and spoofing. Can you elaborate on those for us?
So yeah, there's different types of jamming signals. So they could either be a continuous amplitude of signal, as well as just one frequency, one constellation, one frequency, or they can be varying in their amplitude and varying in their frequencies as well. So it could be wideband or narrowband specific in targeting specific signals. Or they could try and target the whole of GNSS spectrum and affect the whole spectrum itself.
Where in the world have we seen these jamming and spoofing incidents?
They've been prevalent in the Eastern Mediterranean for quite some years, since about 2018 up to today, but it's getting more and more prevalent in the Black Sea, the Red Sea, and in the Baltic Sea as well. Has been prevalent in the last year or two as well. So it's an increasing problem.
And what are the key issues for the ships who are jammed and spoofed?
So for positioning so general navigation of vessels use GNSS for positioning the vessel as it's transiting the seas, because there's no reference point that they can use. So they'll use GNSS for that. So if they have no GNSS positioning, then they can't actually position the vessel. But for offshore, the vessels that are working alongside platforms or doing construction work also have DP on board the vessel. So our positioning goes into that DP system to hold the vessel in its location. And if it loses the GNSS without other systems on board, then it can lose position, and there can be accidents, etc. offshore with a loss of GNSS.
Okay. And what are the main mitigation technologies?
So the main mitigation technology for jamming is the anti-jam antenna. It's really the only thing that can protect against an actual jammer, because you cannot filter out the jamming signal because with just a simple receiver, because the transmitting signal is on GNSS. So if you filtered that out, you would lose all your GNSS positioning as well. So an anti-jam antenna nulls out the jamming signal, but allows the rest of the GNSS signal from all the other directions to be received by the receiver. So removing the jamming signal from getting to the receiver in the first place and affecting it. So that's the main anti-jam technology. Receiver technology for the spoofing side is a little bit different. It's generally done in the receiver itself. Now, an anti-jam antenna can mitigate spoofing if the spoofing signal comes in at a higher power. So it sees it as a jamming signal and will remove it as well. But if the spoofing signal is at the same power as the normal GNSS, then it can't distinguish between a spoof signal and the authentic GNSS signal. So that's down to the receiver technology to mitigate that. So spoofing can happen either in two ways. One is through the navigation part of the message being manipulated, and so the position is wrong in the receiver, or the actual ranges can also be, and data within the messages can be spoofed, and that's another technique of spoofing. So the receivers itself will either do an authenticated navigation message, or they'll do a calibration on the RF environment and look for a spoofing signal, and then use algorithms within the receiver to determine if the spoofing signal is there and warn the user that they are being spoofed, which is a big part of the problem. If you're being spoofed and you don't know you're being spoofed, you'll follow that signal.